Okay, folks, we're talking about section 6.2, rational power functions. Remember the term rational means that we're dealing with a fraction, right? Rational numbers are just numbers that can be written as fractions. Power, obviously, dealing with the exponent. I want to remind you of some simple things like the square root of x is x to the 1/2 if you write it as a fractional exponent. Same thing with x cubed. You can write it as x to the 1/3, or more generically, the nth root of x can be written as x to the 1 over n. Now, if you stick with only positive numbers or 0 for x, then all of these things are the positive roots. All these things represent positive roots. Please don't get that confused with something like this where it says it's not the same thing as solving x squared equals 25, where we say find all the values which make the statement true. Because in that case, you take the square root of both sides, and I know that kind of gets confusing for a lot of people, but this is saying find all the solutions, which would be plus and minus 5. Or in these cases, these are just simplified. Tell me what these individual things like cube root of 8 or square root of 25 or something like that. And all of those are dealing with the positive ones. Now, let's take a look at the fractional exponents, see what's going on here. You have x to the m over n. Now, based upon the properties which you should know, but we'll refresh your memory on here in a little bit. A fractional exponent, or a fraction, can be split apart into two numbers which are multiplied times each other. We know that we can separate a fraction into these two parts, and we can separate, in this case, an exponent into these two parts because we're taking the power of a power. And when you do the power of a power, you multiply the exponents. So we can use the reverse process and split it apart into these two parts. Well, the nth 1 over n is the nth root. So this is really saying the positive nth root of x to the m. Well, there's another way we could have split it up. We could have taken this thing and we could have put the x to the 1, we could have put the 1 over n on the inside and the m on the outside because we're still multiplying the exponents together. So that's still a legal move to have these two things switched, which if you would write that with the nth root, it would be inside with the exponent of m on the outside. That would be the mth power of the positive nth root of x. And I know to many of you that seems like such a ridiculous thing. Okay, why in the world are we writing it separate ways? I guess we can see that you can do that, but what would be the use of doing that? Well, I'm going to ask you a question, no calculator. I know you're loving that idea of no calculator. I'm going to say simplify or evaluate, maybe I should write that in here, evaluate 32 to the 3/5 power. 32 to the 3/5 power. Well, you got two choices. You can take 32 to the third, and remember, you don't have a calculator, so you're going to be sitting there doing the old-fashioned multiplication like you did when you were in elementary school. 32 to the third, it's 32 times 32 times 32. And then once you get that bigger number, then you're going to take the fifth root of it, of which I am guessing many of you will not be able to do. So the better idea would be to do them in this order, right? Take the 1/5 power first, or the fifth root first. In other words, you're taking the 32 and you're making it smaller. Then you can take that number and raise it to the highest power, which is the third. So we have 32 to the 1/5. Obviously, that's a fifth root of 32, which is the number 2, and all of you should know that. I'm going to try to list out some numbers in class of the numbers that you'll need to know, that powers that you need to know without a calculator. Then you can take the 2 to the third power, which gives me 8. So 32 to the 3/5 was 8. You would not have probably found it without a calculator going this route, but you definitely can do it the other way. Let me just review some properties with you. What happens when you take x to the m times x to the n? What do you do with the exponents? We add them together. When you're taking the power of a power, what do you do with this exponent on the outside? You multiply it times all the exponents on the inside. Please do not get this confused with foiling. This is not the same property. Sometimes you guys like to use this property on foiling, which is clearly not the same. So we have n times 1 is n times 1 is also another n. When you are dividing like bases, we know that we are supposed to subtract the exponents. When you are dividing unlike bases, once again, the exponent gets distributed to all exponents in the numerator and all exponents in the denominator. So that makes x to the n over y to the n. In this case, because the x and the y both have an exponent of 1 to begin with. X to the 0, 1. For those of you who said 0 at home, thank you for playing, but no. X to the negative n, just to remind you, some of you are not going to remember this, but let me do a little bit of algebra for you. Negative n is the same thing as 0 minus n. Right? If we use the property that we have up here of subtraction being the same thing as dividing like bases, that would make this x to the 0 over x to the n, which would make that a 1 on the top and an x to the n on the bottom. So x to the negative n is equal to 1 over x to the n. That was the property they were trying to get at. In example 2, another type of evaluate, but this time they're combining a negative exponent with that fractional exponent. And, I like to say that, if you happen to run into a negative fractional exponent in a dark alley, that I have a specific type of self-defense move that I like to use called the root power flip. I think if you get the hang of this, it should be useful to you in several and all situations. First of all, I deal with the root. Then I deal with the power. Then I deal with the flip. Right, this back here, this negative fractional exponent is like a reciprocal. It's like flipping the thing over. So when I say root, this is what I'm talking about. And I say power, I'm talking about the numerator. So we got denominator, numerator, and then the negative 1 is the flip. Well, the cube root of 27, that's pretty easy. That's 3. Raised 3 to the 4th power is 81. Everybody should know that. And flipping it over makes 1 over 81. Piece of cake. Root, power, flip. So practice it. Let's practice another one here. So we got 8 over 125, and we got the root, and we got the power, and we got the flip. Root. Well, the cube root of 8 is 2, and the cube root of 125 is 5. And we square them, right? And that gives me 4 over 25. And we flip them, so 25 over 4. Piece of cake. Root, power, flip. Yes, you'll have to know your roots and your different powers, and I'll give you a list of those. What do the graphs of these rational functions look like? Well, I've listed out 3 here. Y equals x to the 2/5, y equals x to the 1st, and y equals x to the 5/2. Okay, so let's see what the graph looks like. Y equals x to the 2/5. Well, that's going to have a graph that looks something like this. It's y equals x to the 2/5. Y equals x, we know that's that straight line that goes out forever and ever and ever. And then y equals x to the 5/2 is going up like this. Y equals x to the 5/2. Makes a whole lot of sense, because if the exponent is larger than 1, of course it's going to be bigger. And if the exponent's less than 1, of course it's going to be smaller than this diagonal line which cuts through. The only thing that's kind of unusual is what's going on right here between 0 and 1. Between 0 and 1 with all those fractions, that's where you start having those difficulties. We'll see you in class. Make sure you bring. So you thought you were done with the notes. Ha! I tricked you. Okay, so example 4 says, find the volume of the cube with surface area, 93 square inches. Well, if you think about a cube, right, it's got side length S. All the sides are the same length. So one side is S squared, and you've got 6 sides, so that makes 6S squared for your area, surface area. Well, volume is length times width times height, but they're all the same, so that's side length cubed. Well, so if you start out with an area of 93 square inches, dividing that by 6 on the handy dandy machine, 93 divided by 6. Wow, you cannot see that. Tip it up, can you see it? Yowzers. It's ugly looking. Okay, I'll just have to do those off screen. That's 15 and a half, and when you take the square root of that, we get S to be approximately 3.94. That's the length of one of the sides. We would like the volume, so we simply plug it in. Right? V equals 3.94 cubed. So I'm going to take my answer, I'm going to raise it to the third power, and I'm going to get a volume of approximately 61.02, and that is in cubic inches. Well, let's see. Part B of that example says express the volume as a function of the surface area. Okay, so now we're dealing with these two equations again. Now, think about the letter that they have in common. These two formulas have side length in common. So, this says write the expression for the volume as. So, in other words, when I get done, I'm going to have V equals. So I must have to take this equation, area equals 6S squared, and solve it for S. And then substitute it in the other equation, just like we did with the numbers a few seconds ago. So let's see here. So I divided by 6. Okay, I got that done. Take the square root, or I could say that a over 6 is raised to the 1/2 power. You know, be all fancy with my rational exponents. Therefore, we're going to substitute in here a over 6 to the 1/2, which makes a over 6 to the 3/2 power, and that's my volume formula. Volume as a function of the surface area. And one of the homework problems is to do it the other direction, so you'll get the practice of doing that in class. Okay, now I think we're finished.